spaces. The south atrium that Tim showed you, we use that to actually, the same principle, to charge the whole building. We have a much larger area of glazing, large overhang on the roof, it's about 3 metre overhang, a series of solar shades, so in the summer months we're getting full shading in that space. But in the winter we allow that sun to come right in, and we collect the heat from that space, and that heat is then distributed throughout the building. And because it's a social space, lots of activity coming and going, you can allow for that sunlight to come in. It's not going to have glare problems and the like because you've got an active space. So just a couple of examples looking at the model, the lighting models that we did. In the winter you're seeing that sun coming in. On the east elevation we're using that high level sun coming in through clear stories to preheat the workshops. But then the same in the summer, you're seeing extensive shading on all the windows just to keep the building cool. One other aspect is the sun pipes. Now this is a new technology coming out of the University of British Columbia. It's not the same as a light pipe that you're probably familiar with that you get at the local hardware store. This is actually actively tracking the sunlight. So it has a unit on the outside of the building with an array of mirrors that's tracking the sun, collecting that sun, redirecting it, and then ducting it through the building, basically through a large duct, and then pulling it out throughout the deep plan space, trying to take it up to 20 metres into the space. It's a new technology. It's going through a series of prototypes. This project was selected as one of 6 in Canada to do the next prototype as the next demonstration space, with the intent of making it commercially viable for the market. So those are just going in. It's quite exciting to see them going in. So natural ventilation. We rely on natural ventilation for as much as we can during the year, indicated by a simple red-green light system. So allowing the natural ventilation to come in, high ceilings within the space, allowing using stratification to get the buoyancy in the space and vent out through the corridor, out through a series of chimneys along the length of the building. These are the chimneys that you can see, collecting from the workshop one side, from the corridor on the other, and a series of louvers which will open depending on the prevailing wind. We benefit from quite strong prevailing north-south prevailing winds. On the south side of those chimneys, we actually have a window on the south side, and the purpose of that is to actually use the sun on those hot, sticky days when the air is not moving, using the sun to actually heat that air and actually boost the natural stack effect. And the graph on the left shows you the difference between the chimney with and without the glazing. We're getting up to sort of double the performance through just those simple windows. And this is in the closed mode. When the red light's on, the occupants know that the window should be closed. There's no automatic openers or anything like that. It's just low-tech. The users in the space know to close the window when the red light's on, which means that typically it's either too cold outside, or in the summer months it might actually be too hot. It's too hot to use natural ventilation. You want to keep it closed. That's much more exceptional. And in that case, we're using the stratification to get a lot of high temperature at a high level, collect that warm air that's well above head height. That goes out through the corridor, and then we take it through a high-efficiency heat exchanger. The heating within the space is radiant floor heating, which I'm sure you're very familiar with. I won't go into detail into that. And we use the same radiant heating for the cooling of the building as well. We're using geothermal source, so we're using the groundwater from the geothermal well at its natural temperature to cool the building in the summer. This graph that you're seeing is an example in the workshops. By cooling the slab, we actually improve the natural ventilation space. We keep the air cooler for longer, and we can get the fresh air right into the 15 meters depth of the workshop. Whereas without that, it would go above heads and you would not have sufficient ventilation. So with that, I'm going to hand over to Danny.
I'm going to speak more constructability, like what our challenges was. And Jim's a great example of one of these challenges we had. This is a picture of a conventional gym, which uses conventional, forced air systems or electric systems to heat it and cool it, whatever it is. But our challenge was that we didn't have conventional systems. We were using geothermal cooling. So we, as a team, challenged ourselves and came up with an innovative panel. These composite wall panels in the gym, and you'll see it as it goes through the slides here. This is a one of a kind. It's never been done before, as we believe, in North America. These are concrete panels. They're 3 inches thick. They've got the radiant heating in the walls and a cooling duct in the walls to naturally ventilate as well as the structural elements of the glue lamps behind it, which is attached, so it's got the composite action of the concrete and the shear of the glue lamps. So this was a company in Vancouver, Structural Craft, who actually built these off-site. And we went through a whole bunch of testings, and they did all the engineering on it. Again, challenging the process. What can we do? The biggest challenge we had was, and Robert alluded to earlier on, we had a challenge with the site conditions of the soils themselves. The soils couldn't bear the weight, so we had to reduce the weight of the actual building itself to go on the foundation. So again, I think it's on that slide. That's the finished panel. But the big challenge was, how are we going to heat and cool the space, and how are we going to reduce the weight of the panels? If we went conventional tilt-up panels, the foundation just couldn't accept it. So that's the finished space. I was in there on Wednesday. It's very, very comfortable. It was a cold day outside, and we're using geothermal to heat it. It's incredible. It's been another great success, but it was a big challenge to start with. We were all challenged. How could we do it? How could we think differently? So that was another great success within the integrated design. So I'm going to talk more on the red list. Robert alluded to that the red list is very different from LEED. There's quite a number of challenges within that, and we identified that earlier on as a team. The red list, I'll just pick on one good example, PVC. Like PVC, it's used in almost every material we have: mechanical, electrical, irrigation piping. It's extensive through your building systems. We have to eliminate them. We have to try and find an alternative product. So the thing what we did, and we were very proactive as a team, an integrated team, we challenged ourselves to, first and foremost, not give the subtrades any surprises with this red list. It's unusual. They're not aware of it. They don't know what it is. They've never seen it, never worked with it. Big challenge. So what we did was we tried to hard spec as much of the products as we could. And within the red list, then there's the radii of where we can actually source the products from. So again, it created another huge challenge for us. This is a picture of the center of the project, obviously the center of the circle, and then the different bands of the weights of the material, the types of materials that we can purchase. And on this slide, it shows you that actually 2/3 of the radii, it's 1/3 of it is over the ocean, 1/3 is over the northern hemisphere here, and then we barely touch where the major industries and the major suppliers of materials are. So what it told is we have to source very, very much locally, which was a challenge within itself. You know, where do you get steel pile columns from? You know, so we had some challenges. But again, the key to we believe the key to the success was being upfront, being proactive with the red list, hard specking as much as you possibly can, putting it out to the trades. A real quick story on this. I went down to the local construction association in Penticton prior to the project even going out to tender, and met with trades and stakeholders within the industry and within the region, and we challenged them to think differently. Don't be surprised. We're going to do a lot of your legwork up front, so don't be scared of this project, because it was an unknown project. And it's ironic when I was there, when I spoke to that in Penticton, it gets very, very, very hot there. You know, it's 38 degrees, very, very hot. And we said the building has no air conditioning. And my God, you should saw their faces. Like, they're just blown away that we would even suggest a building in Penticton with no air conditioning. And it works. It's fabulous. So this was another big challenge within the Living Building Challenge, FFC lumber. As you know, in LEED, it's mandated, and Living Building Challenge, it was mandated. And again, using